In this lecture, let's understand about conditional compilation using preprocessor directives. Now let's begin. So there are various conditional compilation directives available in C programming language. So these are some of the conditional compilation directives. Now these directives help you to include or exclude individual code blocks based on various conditions set in the program. So now let's explore how to use these conditional compilation directives. Now let's first start with #if and #endif directives. This is the syntax how you should use #if and #endif directives. So you have to write #if followed by a constant expression. So this must be a number or an integer. So like 0 or non-zero value. Here is an example. So #if 0, so here you can write your code block, and scope of this if is marked or decided by the following endif. That's why an endif always should follow a if. So please note that. So this directive checks whether the constant expression is 0 or non-zero value. So if constant is 0, then the code block, that is this code block, will not be included for the code compilation. Remember that. So it will be excluded from the compilation itself. So that means these preprocessor directives will be handled by the preprocessor stage of the compilation. So preprocessor will remove this code in this case. Why? Because this is 0, isn't it? So if constant is non-zero, the code block will be included for the code compilation. And remember that endif directive marks the end of scope of #if or #ifdef or if not def, else, elif directives. So more on that we'll see later. So please don't confuse this if with your decision making if statement. Both are entirely different. So this is conditional compilation directive. So that is a C statement. So that if what we used in decision making is a if statement. So that is checked during runtime of the program. But this is checked during preprocessor stage of the compilation, whether to include a code block or not in the final executable of the program. So in this case, this code block will not be the part of final executable of the program. Let's see how to use this in a program. So now let's see how to use #if and #endif in a program. So now here in this program there are two code blocks. So this code block actually computes the area of a circle, and this code block computes area of a triangle. Now let's say I want to exclude this code block from the compilation itself. So I can comment it out, right? So I can just use multi-line commenting and I can remove that stuff, isn't it? But comments are generally used to give some description or to provide some information, right? So using that to remove a code block is actually not good. And also, what would you do if you want to re-enable this code block? Again, you have to remove these comments, right? That is actually a bad idea. Instead of that, you can use preprocessor directive #if. So I can use #if here. #if 0. A #if must be terminated by its associated endif. Endif actually decides the scope of this. Now let's say I want to disable code up to here. Okay, so that's why I would give endif here. So that's how I remove a code block. So now this code block is actually excluded from the build itself. For example, I can type some random things here. So this would have given error before, but now you see there are no errors. So it builds fine because this is excluded from the build, right? So now if you want to enable this code block again, very simple, make this as non-zero and you are done. So that's how you use #if and #endif. Please note that you should remember 2 points. One is it must be a constant expression here, and this #if must be terminated by its associated endif. Okay, otherwise you will face problems. Let's say inside this code block, I want to disable this line. Again, you can use nested #ifs. #if 0 endif. So this endif belongs to this one and this endif belongs to this one. So here this code block is removed from the build. So now let me make it 0 and let's see how the output behaves. So when I run this code, you can see that it directly goes here. It is not executing this one. Now let's understand hash if, hash else and hash endif. So you can also use hash else in between hash if and hash endif. This is an example here. So here a hash if constant expression is 1. So code block 1 will be included for the build and this code block will not be considered for the build. Suppose if this is 0, then code block 2 will be considered for the build. Now here, if I want to use hash if, hash else and hash endif, so what I would do is very simple. So here I would remove this. If 0, hash else endif. So here we want to execute either one of these code blocks. In that case, you can use hash else directive along with hash if and hash endif. So here this is false. So that's the reason this is included for the build. Now if this is true, so let me make this true. So now this is included and this is excluded. So that's why use hash else when you want to execute either one of code blocks. Now let's explore about hash if def. As its name indicates, so this is slightly different from hash if. So here as its name indicates, so the evaluation of this preprocessor directive depends upon definition of a macro. So that's why it is called as hash if def, that is if defined. So that's the reason we use an identifier for the evaluation, so not a constant expression. So hash if def, so there is a space and you should use an identifier. And as usual, you have to use an endif to terminate the scope. Alright, so here is an example. So what this tells to the preprocessor stage of the compilation is that if this new feature macro is defined in the program, then only include this code block, otherwise exclude this code block. So that's the meaning of these statements. Now let's see how to use this in the program. Execute triangle area calculation code block only if area underscore try macro is defined in the program. Now let's see how to meet this objective. So you have to execute the triangle area block only if a macro area underscore try is defined in the program. Now let's get into the code. So since the decision must be taken on the definition of a macro, we cannot use hash if. We have to use hash if def. Alright, now let me remove this first. So hash if def area try. If this is defined, then only include this code block. So endif. So we can achieve this objective making these changes. So here in this program, this macro is not defined, right? So that's the reason this code block is disabled. Now, if I define that macro in the program using hash define, then you can see that that code block is enabled. So if you can't able to edit your source file to include this statement, you can also send this macro name as a compiler argument. So now let's see how to do that. For that, copy this macro name, go to settings, go to properties, settings, and here go to GCC compiler, preprocessor, and add your symbol, okay, or macro name. All right, and then apply, yes, and close. Here you can see that this code block is automatically enabled. When you compile this code, you can see that that macro name is passed as a compiler argument by using the option -d. So I hope you are getting this. If you don't want to give this as a compiler argument, then you can also mention in the program itself by using hash define. Now let's define that. Now let's see what is our next objective. Execute circle area calculation code block only if area underscore sur macro is defined, and execute triangle area calculation code block only if area try macro is defined in the program. So how do you do this? So you have to put one conditional compilation macros here. Now here you have to make this as conditional compilation code block by using hash if def area sur and endif. Here you can see that this is defined, right? So that's why only this is enabled, and since this is not defined, this is not enabled. Whenever you have a macro which is already defined in the program, but if you want to undefine that, there is one trick. You need not to disable this. What you do is use undef, hash undef. So now you can see that both are disabled. Let's imagine this is defined in some other file or by someone else. Still, we can override that using hash undef in your program. So here this is defined, this is undefined. That's great. Now let's see one more example. The example number 3, execute circle area code block only if area underscore try macro is not defined. How do you do this? So first let me remove all these things. So execute this code block only if area try is not defined. So that means if area try is defined, then you should execute this and you should not execute this. So in this case, we can make use of hash if not def. So here is an example. So the meaning of this code block is if new feature is not defined, then execute this code block. So that's why for this use case, we have to use if not def. So we have to use hash if endef not def area try endif. This we can guard using hash if def. Now here you can see that since this is not defined, so this code block is enabled. So the moment I define this macro, and this is enabled. Now you can also use hash else along with hash if def. So here is an example. If the new feature macro is really defined, then code block for new feature will be included. So if new feature macro is not defined, then it is assumed that program should include the code block for old feature. So that's why if this is not defined, then this code block will be included for the build. Alright, so in the next lecture, let's learn about hash if and defined operator. Okay, I'll see you in the next lecture.